supposed to yell at me and say, wait a minute, coach, I can't see anything that you are projecting right now.
I was about to say that, but I thought, because last time I said it, you said you did it on purpose.
A likely story. Did it on purpose. Ha! No, I was a goober this morning. I forgot. Sorry about that, fellas. Here, I'll share my screen with you guys. Post haste. All right, now you guys see what we're talking about, and y'all can kind of get caught up. We're not too far behind as far as letting y'all get caught up. There's that. Colin, can you see it? Can you see this?
Yes, sir.
All righty. Sorry about that, boys. All right. Okay. So the pattern here. Look at what I'm doing. The pattern is. Wait a minute. Where's my green one? Right there. Okay. If x to the third is 1 times x times x times x, and x to the second is 1 times x times x, and x to the first is 1 times x, then that exponent really becomes how many x's follow the number 1. And so based on that pattern, what would y'all say x to the 0 is? 1. Again, we need to see that pattern right there. The exponent is the number of x's that is following my coefficient of 1. So what we want to make sure we understand is that, and can we all write this down, that x to the 0 power equals 1. As long as x is not 0 itself, because I couldn't raise 0 to the 0th power, that's undefined. Okay, but guess what? 5 to the 0, 1. 11 to the 0, 1. Negative 42 million to the 0, 1. Okay. Any non-zero number raised to the 0th power, what does it equal, class? 1. It equals 1. Very good. Okay. Now, let's consider negative exponents. Here's what we do about negative exponents, okay? And we're going to talk a lot about negative exponents today, but if I want to make this x to the negative third, here I'm going to zoom in a little bit. If I want to make this x to the negative third have a positive exponent, all I have to do is put him on the bottom of the fraction. Now, there's not any other things going on with x to the negative third. It's just, 1 x to the negative third. So I'm going to say 1 over x to the positive third. And that's 1 over x times x times x. And as I mentioned, we'll talk a little bit more about negative exponents, but the gist of it is, if I've got a negative exponent, change his position in the fraction and make him positive. So x to the negative second is going to be 1 over x to the positive second. X to the negative first is 1 over positive x to the first, also known as 1 over x. And what do you think x to the 0 is again? 1. Because there are no, again, here's that pattern, right? There are no x's in the denominator. It's just 1 in the denominator. 1 over 1 is just 1, but we've already said that over there. Okay. So understanding exponents as the whole number exponents as the number of bases that you're multiplying times whatever 1 is times that coefficient. And by the way, if I wanted to change that coefficient, like if I wanted to make that 5x cubed, then it would just be 5 times x times x times x. The coefficient isn't being exponentiated. The variable was. Tiago. You're thinking about a negative base. Now, Tiago's brought up a real good point that we need to consider, okay? So, like, for example, everybody check this out. Look, negative 3 versus negative 3. All right, is there a difference? Okay, James is a non yes. James, what's the difference? What's the one over on the left going to equal? Negative 9. And the one over on the right? Positive 9. Okay, that's a big fat difference, right? Because what are we exponentiating there? If the negative is in the parentheses, we are exponentiating both the negative, we're squaring both the negative and the 3. But if there is no parentheses, following PEMDAS, this is over on the left, this is like saying negative 1 times 3 squared. And what do I do first, George? 3 squared. I got to do the exponent before I do the multiply. All right. Second follow-up question here, okay? Negative 3 cubed, negative 3 cubed. Is there a difference there? No. Because again, I'm exponentiating first, take care of the cube first, and then apply the coefficient of negative 1. 3 cubed is 27. And what's negative 3 times negative 3 times negative 3? Negative 27. So we bear in mind there can be a difference based on the exponent being even versus odd. So that's one point from Tiago's comment. Second point from Tiago's comment is that the base in these examples was, we were discussing whether or not the base was negative. Okay? A negative base, when there's an even exponent, is going to lose its negative sign because an even number of negatives multiplying together. So like, for example, if I said negative x to the n, right? That's negative x times negative x times negative x times dot, dot, dot times negative x. I don't know how many there are, but I do know how to represent that. There's n factors. So if n is even, there's an even number of negatives, and therefore the negatives will go away and our answer will be positive. Okay, so from Tiago's point, negative x to the n equals x to the n when n is even, and negative x to the n equals negative x to the n when n is what? Odd. Tiago, does that tally up with what you were thinking? All right, real good point to be made there. And again, if there's a difference between having a negative base and having a negative exponent, okay? So when there's a negative exponent, that's when I'm doing my 1 over and putting it on the bottom, okay? Again, we'll get back to negative exponents here in just a tick. Everybody got what I got on the screen? Can I slide over? You ready? All right. Let's talk about our exponent rules. Here's our first rule. And I don't know about you guys. I like popcorn. Popcorn's one of my favorite snacks. Okay, Alex? You got a favorite kind of popcorn? Are you a fan of the popcorn?
I like it now.
I don't have a favorite flavor. Anybody got a favorite flavor of popcorn? Any kind? Quentin, I saw your hand go up first. Caramel corn? Okay, James?
Extremely buttery.
Extreme butter. Okay, anybody else? I'm a cheese man myself. I like cheddar popcorn, cheddar cheese popcorn, or white cheddar popcorn. Ooh. Teddy's in the Cub Scouts. And what do Cub Scouts sell usually? They usually sell popcorn, the most expensive popcorn known to man. Okay, but as a fundraiser, it's pretty cool. I think they keep about 70% of what they charge, so that's not a bad fundraiser at all for the little cubbies. But you made me think, James, when you said extreme butter, they sell this flavor called extreme butter. But anyway, popcorn. There's 3 of these basic rules, and they're kind of sprinkled in throughout this list that I call the popcorn rules of exponents. This first rule is one of them. It's the product of powers, P-O-P, pop, okay? Product of powers. When the base is the same, and you're multiplying these 2 things, in other words, you have a product of these 2 things, and these 2 things are raised to a power, what we do with the powers is that we add them. We add the exponents, okay? So look down here at my little example 1 here in black with me. It says x to the second times x to the third. And the long drawn out way of doing this would be to say, oh, x squared is the same thing as x times x. And x cubed is the same thing as x times x times x. And therefore, you guys would tell me how many are there. Yeah, that's the same thing as x to the 5th. Well, the shortcut would be to say, hey, we could just add these 2 up, get 2 plus 3, and therefore have 5 as our result, okay? And this really pays off when it's something like x to the 27 times x to the 32. Ain't nobody in their right mind going to want to write out 27 x's and then 32 x's and then count them all up. It's very obvious, very intuitive that we could just add their exponents. So that's our first rule, okay? Now, I don't know about you guys, but I always look at addition and multiplication like they're almost like they're first cousins, okay? As far as operators go, the symbols even look very similar. The plus sign, if you rotated it 45 degrees, it's dead-gum multiply sign, okay? Do y'all study foreign language? You guys take anything? What do y'all study? Espanol. Oh, muy bueno. Okay. In Espanol, certain words have a gender assigned to them. You guys knew that, right? You have masculine words like el, is it gato? ¿Cómo se dice el gato en inglés? Cat, meow, meow, meow. A cat is a masculine word in Spanish, in Espanol. Abuelo, abuelo. ¿Cómo se dice abuelo en inglés? Grandfather. Abuelo is a masculine word. Abuelita, abuelita in Espanol is a feminine word. Okay, so we assign these genders to these vocab words oftentimes in foreign languages. We don't typically do that in American, you know. But in math, this is the way my crazy little brain works. I oftentimes look at addition and multiplication like they're the masculine operators. Okay, and they kind of go together. So I want you to remember when you're multiplying and the base is the same, you do what with the exponents? You add the exponents. Multiply goes with add. Multiply goes with add. Multiply, add. Okay, so when you're multiplying the two and they have the same base, we're going to add. Look at example 2 with me here. Okay. Now example 2 has a C word. What's that C word in front of each variable? Coefficient. And because we got the commutative property of multiplication, we can actually rearrange these. So I could put on the back burner, I could say 2 times 3 times y to the 7th times y. And I could choose to do 2 times 3 is 6. And y to the 7th times y is what, class?
8.
Y to the, why did I write an equal sign? Y to the 8th. Y to the 8th. Now you say 8, and I agree with you, but somebody explain to me where the 8 came from. Why the 8, Paul? Oh, now, brown cow. All right, and we add the exponents because those two bases were being multiplied. What if the two bases were different letters? What if it was x? Lewis, what do you think? What if it was x to the 2nd times y to the 3rd? What can I do there?
Well, they're not like terms, so you can't do anything.
They're not even daggum terms. They're factors. But you're right. I can't do anything. It's just x squared y cubed. You just leave it. Unless they have the same base, don't you dare add the exponents. Okay? Because those two letters are different, it's just, sorry, apples and oranges. Can't do anything with it. Tiago? All right, all right. Here's our next example. Why don't you guys take a stab at example 3? Again, we got some coefficients to consider. We got some exponents to consider. The base is the same, that base of z, but this one's a little bit kooky, and then I have a variable exponent. The rule still applies. The rule still applies. (3a) is 3a. It's just your exponent. Play ball by the rule. All right, play ball by the rule. See what you get. We'll ask Andrew. Andrew, what'd you do with your coefficients?
Do basically 5 times 1.
Very good. So that's 5. Okay. And let's see here. Will tell me about my variable. It's going to be z to the what?
Z to the 4a.
Excellent. How'd you get 4a? You what?
I added.
You added.
A.
Yeah, we just add the exponents. Just like we did with the 7 and the 1, just like we did with the 2 and the 3. Here we add the a and the 3a, and we get 4a. It's just that simple. Now, I don't know what the dump 4a is, but that's okay. Okay? The rule applies no matter what the exponent is. Okay? We add them together. Questions? Preguntas. See, that's questions in Espanol. All right, I have a joke to tell you. You're not going to like the joke. I'm going to go ahead and warn you. Okay? But I enjoy telling it, so it's all good. Once upon a time, there was a frog. And this frog hopped off his log and on into a bank and hopped up to the loan officer's desk. And he sat down at the chair opposite her and he said, "Ribbit, ribbit, I would like a loan, please." Now, this particular loan officer's name was Patricia Wack, and she had worked at this bank for quite a while, and she thought she'd seen it all, but she'd never had a frog hop into her cubicle and sit down opposite her desk and ask for a loan. So she, very much beflummoxed, still nonetheless was going to perform her duties. So she said, okay, Mr. Frog, you want a loan? What kind of collateral can you offer? What kind of collateral can you put up for this loan? Collateral, you guys understand, is if the person doesn't pay the loan back, the bank takes the collateral to help compensate them for their loss. And so the frog says, aha, I thought you might ask that. Ribbit, ribbit, here is my collateral. And he set down on her desk a ceramic pink pig. And she was like, huh? What? What kind of collateral is that? And he said, well, if it helps, my dad is Mick Jagger. And so at that point, she throws her hands up. She's like, I don't know what to do. Hold on, I'm going to go get my boss. And so she goes to the manager's office, and she gets the manager. She brings him back on over here, and she said, look, this frog hopped into my cubicle, sat down at my desk, or opposite my desk, and asked for a loan. I inquired about collateral, and he showed me this ceramic pink pig and told me his dad is Mick Jagger. And I don't know what to make of this. What do I do with this? And the manager looked at her and pointed at the pig and said, knick-knack, paddywhack, give that frog a loan. His old man was a rolling stone. Hey! I told you wouldn't like it. But it's still a good joke, nonetheless. Come on. No, the dancing cookie is long gone, my man.
I don't trust you about that.
Knick-knack, paddywhack, give a dog a bone. His old man is a rolling stone. This old man is a... Y'all heard the old man, right?
Yeah.
Okay, good. You didn't see that coming, though, I bet. Oh, all right. Here's our second exponent rule. And much like the first one, this one kind of goes hand in hand. But look at the operators. Instead of multiplication, the operator is division. Okay, and much like I said with addition and subtraction, addition and multiplication, I feel like these two are first cousins. Look at their daggum signs. The symbol for subtraction is almost identical to the symbol for division. I kind of look at them, and then this is the way my crazy little brain works, but I kind of look at subtraction and division as the feminine operators of our arithmetic, right? You got the masculine, and you got the feminine. Again, at least that's how my brain kind of sees it. But these two pair up and go together. Okay? These two pair up and go together. And so when we are dividing the two bases that are the same, we will subtract their exponents. Now, really, I don't like the way that the book phrases this. So what I'm going to do is I'm going to just scratch through all of this, right? And just say, hey, look, here's my rule. And if you get to a spot where you're subtracting, you're like, well, wait a minute, coach. What if there's more on the bottom than there is on the top? And oh no, I get a negative exponent. Well, I say just take them and learn about negative exponents. Don't be shy. Okay, don't be scared. So if I've got a to the m over a to the n, that's a to the m minus n. It's just all there is to it. Okay. Now, if m is the bigger number, like I've got right here, then that's cake. That's easy. All right, check this out. We could even consider it the brute force or the slow way, as we did in the last example, by writing out x times x times x times x times x on the top and x times x on the bottom. And then as we do with fractions, we can cancel common factors, 2 on the top, 2 on the bottom, cancel those out, and we got x to the third. What would be my shortcut then? Just subtract 5 minus 3. The base is the same. I'm dividing, so 5 minus 3, sorry. 5 minus 2 is 3. Okay? So when we get our exponent on top and our exponent on bottom, we can just simply subtract, and that's the shortcut. Even if there's more on the bottom, if that fraction's got junk in its trunk, so to speak, that's okay. What's 2 minus 3? -1. Last time I checked, x to the negative first, the same as 1 over x to the positive first, hence our answer. Now, the shortcut is so nice, especially when the numbers get big. If I've got like x to the second over x to the third, I could go the slow route, certainly. If I got x to the second over x to the third, we could say x times x on top, x times x times x on bottom, and then cancel a couple x's on top and bottom. Bada bing, bada boom, you got 1 over x. But what if this was x to the 23 over x to the 35? I'm not going to want to write all those x's out. I'm going to do a simple subtraction, right? What if time out. What if that was x to the 23 over x to the 35? Okay, what's 23 minus 35? And x to the negative 12 is 1 over x to the positive 12. Speaking of negative exponents, okay, in Algebra 1, I want you guys to hear me on this. You guys at home as well. It's considered unconventional, one might say. It's considered bad form, like having your elbows on the table at supper, okay? It's considered bad form, unacceptable to leave an answer with negative exponents in algebra, okay? As an exercise, we teach algebra students to get rid of the negative exponent. So I would not accept x to the negative 12, but I would 1 over x to the positive 12, okay? And once you guys get on into calculus, then we slacken up a little bit and we say, you know what, it's probably okay. But the whole point in algebra is so that you learn to manipulate the expressions to where you're versatile. You can have it either way, okay? So that being said, look at these two exercises before we have to go today. Look at these two exercises and consider what would we do if we had the negative exponents, okay? Example 4, part A is easy. That's cake. All right, we got x to the 9th over x to the 7th. Joey, what's that going to be? Try again. You got 9 minus 7 is 2, so that's the 2. All right. We got Jake, we got 3 to the 10 over 3 to the 2. What's that going to give me? 3 to the 8. I don't know what 3 to the 8 is, by the way, so I'm just going to leave it as 3 to the 8. Okay? Let's see here. Ben, we got b to the 8 over b to the 12. What's that going to give me? Do subtraction. Wait, did you just say x? Where do you see an x? I'm going to say b to the what power? B to the negative 4th power. Very good. How'd you get negative 4? Get out of your notification. You did 8 minus 12. It's the number on top minus the number on bottom. Now, is that acceptable, class? No! So I could rewrite it as 1 over b to the positive 4. Tiago. Oh, very similar to what we saw earlier. So if you didn't hear that, what do I do if the numbers on top and bottom are not the same? So like x to the 2nd over y to the 3rd. Just leave it like that. I can't do anything with it. That's oil and water, right? Now, if I gave you something like x to the 2nd, y to the negative 3rd, I would expect you to move that negative 3 down to the bottom and make it y to the positive 3. But, you know, outside of that, I couldn't do anything else. If the numbers aren't the same, don't you dare combine them. All right, so very good. Thank you much. And how about this last one? We got 7 to the 3rd over 7 to the 5th. Nate, what do you think about that? 7 to the negative 2nd. Now, that's not acceptable, so I don't want to leave that as my answer. I'm going to write it 1 over 7 to the positive. And I do know what 7, positive 2, I do know what 7 squared is. That's 49. And so also in your notes, you should write down, fellas, that when you can, give the actual like numerical simplified out answer, please do that. Like we should not leave something as 1 over 7 squared. That's lazy. Everybody and the brother ought to know what 7 squared is. Savvy? But if it's something like 3 to the 8th, I don't know what the dump 3 to the 8th is. I don't have a calculator on hand, and so I'll just leave it as 3 to the 8th. Okay? Now that means that some of us will be able to do more than others. Like 5 to the 3rd is what? 125. Not everybody might not know that. Or not everybody might know that. So we want to make sure that we are not lazy. And then look down here at properties of negative exponents. We've already talked about this a little bit. But x to the negative 5 would be what? 1 over x to the positive 5. Very good. 10 to the negative 3. I hope you all are writing this down, Alex. Alex, is that all you've written down today? Come on, dadgummit. Alex, help me out. What's 10 to the negative 3? And don't be lazy. 10 to the 3rd is? What's 10 times 10 times 10? 200. What? Okay, what's 10 times 10? Times 10. 1,000. Thank you, goober. All right. Now, if y is raised to the negative 4th power and it's at the bottom, we need to move it up to the top. The way I describe it is I liken it to my children. When my children have a bad attitude, when they have a negative attitude, you know what I make them do? I make them move around. I'll tell Teddy, go outside and run a lap around the house. We live on 2 acres, so it takes a while. I'll say, Betsy, go upstairs and help your mama. Or if we're upstairs and Jenny's acting a fool, I say, Jenny, go downstairs and clean your room. In other words, I move them, get them moving. So if something has if a factor has a negative exponent and it's in the bottom, move it to the top. So that's the same thing as y to the positive 4. This is the same thing as 3 to the positive 2, also known as 9. Okay? So when we're dealing with negative exponents, if it's at the bottom, move it up. If it's at the top, move it down. Gosh dog it, I need more time with you guys. Y'all hold your horses. We're going to go through a couple of little sidebar examples. Okay? You're not in a rush to get on out of here, are you? No, Coach Morgan, we love you. We want to be in your class all day. Y'all don't have some goofy harvest festival to go to today, do you? Huh? They don't do that anymore at y'all's age, do they? All right. Which factors, Joey, should I move from the top down to the bottom? Which factors? A, B, or C? All right, I'm going to move C. He's not the only one. Remember, if Jenny's upstairs and she's got a bad attitude, Jenny, go downstairs and clean your room up. Okay, so which one has a negative attitude or a negative exponent besides C? B. So we're going to move both of these guys. We're going to put the B downstairs and we're going to put the C downstairs. All right. What on the bottom, Alex, is going to get moved up to the top? Which factors? Alex, which factors from the bottom are going to go up to the top? Oh my goodness, son. Do you see any other letters with a negative exponent? X is going to go up to the top too. Woo! All right, we're almost out of time. You're slow playing it on me. All right, check this out, boys. We're going to move. A squared is not going to move at all. A squared, he's positive. He's got a happy attitude. He's not moving anywhere. All right, but we're going to move the B down to the bottom, so it becomes B to the positive 5. We're going to move C down to the bottom. It's going to be C to the positive 3rd. We're going to move X to the top, and it's going to become X to the positive 1st. We're going to move Z to the top. It's going to become Z to the positive 5th. And then don't forget Y squared was down at the bottom. Y squared was gravy. Did not need to move at all. Whoops. Did not need to move at all. All right, so let me get rid of these goofy arrows. Why are y'all packing up? It's time to go, isn't it? Hey, look, I'll have to stop here. We've got a lot more to talk about with exponents, but I'm not going to see you again for another week. Now, let me yell at you guys just for a second. Why are you not doing your homework? Hardly any of you guys is doing any homework on deltamath.com. Every week, I put assignments up there for you to practice. What the dump? Over Thanksgiving break, can we please, pretty please, log on and do some of our homework? I know that I'm not taking anything up for a grade this year, but you need to practice. You need practice. Are your teachers teaching you the same exact things every day that I'm teaching you? So I would assume that they are not assigning you homework on the exact same things that I'm teaching you every day. You need to practice. So if you're not doing your Delta Math homework, please consider doing some, if not all, over the Thanksgiving break. I'm sure you'll be at home with nothing to do, and you'll just think, haha, I'll do some math homework. Live Jesus in our hearts. All right, thank you, fellas. Y'all have a great day, and be safe and be healthy. Some of y'all are like, he's assigning homework? What?
So we don't have class next week, do we?
No class at all next week.
Thank you.
All right, you bet. Y'all have a great week.